Hello everyone, today we are going to solve for c of 1, c of 2, and c of 3 so that g of x equals 0 on the interval from negative infinity to infinity. And we're also going to determine whether f1, f2, and f3 are linearly independent on the interval from negative infinity to infinity. So what we have here is that f1 of x is equal to 4 plus x, f2 of x is equal to x, and f3 of x is equal to x squared, and we're also given the equation for g of x. So now our first step is to plug in the three terms we have into the equation of g of x. And when we do that, our result is c of 1 times 4 plus x plus c2 times x plus c3 times x squared. So now our next step is to distribute that c of 1 to the 4 and the x. And when we do that, our result is 4 c of 1 plus x c of 1, and the rest remains the same. So now our next step is to factor out the x right here in the x times c of 1 plus c2 times x. And when we do that, our result is 4 c of 1 plus x times c of 1 plus c of 2. Now we want to determine c1, c2, and c3 when g of x is equal to 0. So in order for this equation to be true, these three terms right here all have to equal 0. So let's start with c of 1. So for this term, 4 times c of 1 equals 0. It is only true when c of 1 equals 0. Now here we know that c of 1 is equal to 0, so we have c2 times x equals 0, and this is only true when c of 2 equals 0. And for the last term, c of 3 times x squared equals 0. This is only true again when c of 3 equals 0. So now knowing this, we have that c of 1, c of 2, and c of 3 all equal 0 on the interval from negative infinity to infinity. Now, since this is the case, f1, f2, and f3 are all linearly independent since c of 1, c of 2, and c of 3 are all equal to 0.